Hi, and welcome back to the Platinum License Installer program. We want this segment to discuss heat sinks and how the LEDs work. A very basic description is a current causes electrons to flow from an N-type to the P-type side, which releases energy in the form of light, which is what we call photons. Now, a more detailed description is that an LED is a diode, not a bulb. A lot of people are confused. See, a diode is a device that conducts electricity and current in only one direction. Whereas, unlike the bulb, they will work in an electrical current flowing through in either way. So an LED will only work with the current flowing through it in one direction only. So an LED is made up of semiconductors, which are materials that have a varying ability to conduct electricity. So inside an LED, there are two types of semiconductors. One that has an abundance of electrons, and inside we have N-type. These are blue. There are two types, and the one that has room for more electrons, we call it P-type. Here's the red one. P-type semiconductors can be thought as having many holes for electrons, and as they fall into, a quick chemistry reminder, electrons are negatively charged particles that orbit atoms. So the flow of the electrons is what we normally call electricity. When an electrical current is applied to the diode, the electrons travel from the N-type side to the P-type side. When the electrons fall into these holes, think of it like if you drop a ball into a hole. When this ball does drop into the hole, it transfers to what we call electrons and releases energy. The really amazing thing though is that the energy from the electron falling into the hole is released in the form of a photon, which is a particle of light. This continuous movement of electrons falling into these holes releases light, causing the LED to glow. Now, this phenomenon doesn't create as much heat as the earlier incandescent bulbs, so it's more efficient. There is a common myth that LEDs don't require heat sinks. The truth is, the main thing that reduces the lifespan of the output of the LED chips is in fact heat. Let's look at the basic construction of a light. The above figure 1, the LED chip shows mounting it onto a PCB. This is commonly referred to as the printed circuit board. Once it's mounted onto the board, it's mounted onto a heat sink. Then you've got the more gaps, the joints, the plates, and you have more resistance. The heat has to go through to escape. The more heat that builds up, the hotter the unit gets. Higher the heat, lower the lifespan, lower the output. The higher the temperature, the lower the heat is a major factor that reduces the lifespan and its output. We discussed this earlier in one of the segments where temperature junction or junction temperature, and that's where those two type of the reaction is caused, where the P-type and the N-type meet. That's where most of the heat is caused. So now let's look at the different varieties of heat sinks, or if any, that you see on majority of the fittings. Well, the answer to that question is no. And as you can see up here on this chart up here, there's four main types. We have pure aluminium. It has the best thermal compatibility in its aluminium purest form. However, it's more expensive than any of the other methods, but it does have its limitations and also sizes and styles, etc. Now, although not the cheapest heatsink material available, we have the extruded aluminium, and as you can see I have one here. This you'll see on the majority of all of the M-Elec's premium downlight range. So it does have a very fantastic WMK rating. These are easy also to customise. WMK rating refers to the thermal conductivity, also known as lambda, watts per square metre of a surface area for a temperature gradient for Kelvin for every metre thickness. As you can go back to the chart here, number 3. A third option comes the cast aluminium, which has a much lower thermal conductivity, more than half as the extrusions. It is a cheaper option with a much lower WMK rating. However, its purpose is there. It still does get rid of that heat, but just not as quickly, not as effectively as the extruded. As manufacturers and importers that look for methods of cutting the costs, and they come out with ideas like this one here, for example. I mean, it doesn't have any heat disbursement at whatsoever, or very little. The only thing this is going to do is going to shorten the lifespan of the fitting itself, so you're going to have to replace it, and the light levels will reduce much quicker and faster. Are all heat sinks created equally? The answer is no, but try and get the best for that application and to affect the longer lifespan of your LED chips. Thank you again.